Hello everyone. Today let's go over a medium question that I just solved 30 minutes ago. This one is called absolute continuous subarray that is less than or equal to the limit. So essentially the question is pretty simple. You're given an integer array and an integer limit, and you want to return the size, the length of the longest contiguous subarray with the biggest and the smallest element of the subarray being less than or equal to the limit. And so as you can see here, the limit is 4, so 0 minus, or 8 minus 8 is 0, is less than or equal to 4, so the result will be 1. And then here, 6 is bigger than 4, so 2 is not a valid result. So we shrink the window, and 2 is another valid result, but 1 is not greater than the historical result, and we keep going until we find the biggest possible one. So you can do this using a brute force approach, but that's going to be O of n squared, which is simply get all the subarrays of the integer array and ask the same question every single time. But a better way to do this that I discovered is to use, I'll just show you the O of n squared solution first. So for example, we iterate over the array, and then we use another pointer to get each subarray. And then we ask if the maximum of the subarray minus the minimum of the subarray in absolute values is less than or equal to limit. If it is, then simply update the result with the length of the current subarray, and then return the result at the end. So this will not work because this is essentially brute force, and this is very expensive because each turn you're calling maximum and minimum again and again. The better way to do this is to use a nice collections tool in Python called a sorted list. So this is essentially, we're going to be using a sliding window technique, and we're going to be increasing the window and shrinking the window based on whether or not we fulfill this condition, because we want a non-empty subarray, which means it has to be contiguous, as mentioned in the description as well. So to create a sliding window, essentially we are going to keep expanding the window as long as the new element minus, or the biggest element minus the smallest element in the current window is satisfying the limit, and then shrinking the window when it does not, shrinking the window from the left side. So for example, if we have 8, 2, 4, 7, we're going to expand the window. 8 is fine, 2 is not fine, and we're going to shrink the window from the left. We're going to kick out the left character, and then we're going to keep adding, and we're going to ask the same question again. That's fine. This is not fine because there's a possibility of a 5 here, so we're going to, again, shrink the window, kicking out the left character, and then, as you can see, the result here is 2. So, cool. Now let's code it up. So to do that, let's create a pointer starting from the beginning of the array, and then let's create a sorted list in Python to get the maximum and the minimum in O of 1 time, which is really handy, or else this is going to get really messy because you have to get the minimum and the maximum every single time, and you're going to have to do something like use a min heap and a max heap, which can get pretty messy. This is a lot cleaner in my opinion. So let's iterate over the array. So at the beginning, right and left are both at index 0. And then we are going to add, which is the method call for a sorted list. We're going to add the current element. So we're expanding the window by 1. And now we're going to ask the question if absolute value, because that's what it says right here, absolute difference of the, because we know the biggest one is going to be at the end, minus the smallest element, which we know is going to be at the beginning. If it's less than or equal to the limit, then we got a winner. So we can keep track and update our historical result to the length of our current window, which is the length of the deck, or right minus left plus 1, because 1 index, 0-based indexing, same thing. If this doesn't satisfy the limit, as we said, we're going to kick it out of the left side. So you have to be careful here because we want to remove nums of left, because left is the beginning of the window, and also increment the left pointer and you want to remove it before incrementing the pointer, because this left pointer is used to keep track of the left boundary of the current window. And yeah, after this, I think we can just keep going. Again, we're going to add again and then ask this question. If not, we're going to remove. And then at the end, we can just return the results, I believe. And that will give you the correct answer. So basic sliding window technique, O of 1, operations to find the minimum and the maximum due to the sorted list. So it's very handy. And I hope this video was helpful and this made sense. And just shows you that, there are a lot of different tools that you can use in Python to get rid of, to reduce the time complexity. Because if I were to call maximum and minimum every single time here, that would be O of n time for each and every operation, which is extremely expensive. And so yeah, thank you for watching, and hopefully this is helpful. So